Plasma, the fourth state of matter. It represents more than 99% of the total matter in the universe. Thermonuclear fusion of light atoms is the energy process which powers the stars. In the core of the Sun, fusion of hydrogen nuclei occurs at 15 million degrees. At that very high temperature, only the plasma state can exist. On Earth, physicists and engineers are involved in large experiments where very hot plasmas are produced in order to create artificial stars, which will be the source of unlimited energy used to drive a new type of electrical power plant, fusion power plants. When we enter the experimental plant site, we see large buildings which will receive different components of the fusion reactor. In the tallest building, the reactor device is under construction. In the assembly hall, some components are being tested and spare parts are stored. In the Sun, the hot plasma is confined by gravitational forces. On Earth, one way to confine plasma is to immerse it in a large magnetic field, created by superconducting coils. A view of the device placed in a cryostat shows the surrounding superconducting coils, which will produce magnetic fields more than 100,000 times stronger than the Earth's magnetic field. At different levels of the fusion energy plant, we find heat exchangers, plasma diagnostics, computer interfaces, power supplies, pumping systems, high-frequency sources and couplers, neutral beam injectors for plasma heating, remote handling tools, and other systems. The magnetic field will confine the plasma in the heart of the toroidal chamber. This contains components made of different materials, which will be subjected to large amounts of heat and particles, such as the diverter in the lower part of the torus. In-vessel remote manipulators place components inside the tokamak reactor and change or repair them during the operating lifetime of the fusion reactor. Once the fusion plant becomes operational, the nerve center of the site is the control room, from where operators, scientists and engineers drive the device. Long pulsed discharges of plasma are fired. Additional heating is applied until the fusion plasma can burn by itself, self-sustaining the plasma reactions and producing a net gain of energy. In commercial reactors, usable electricity is then produced.
3, 2, 1.
This is the adventure of the Starmakers, which is now taking place to develop a safe, clean and quasi-unlimited energy source for the future well-being of mankind. Fusion is one energy option for the future.